Hello and welcome to this new tutorial. So we just made the proof of work and now we have one final thing to do in this part 1 building a blockchain. It's a function that will check if everything is right in our blockchain. And by everything is right, I mean we're going to check two essential things. First, we're going to check if each block in the blockchain has a correct proof of work. That is, has a proof of work that solved this problem by returning a cryptographic hash that starts with 4 leading zeros. And then the second thing we're going to check is that the previous hash of each block is equal to the hash of the previous block. And by checking these two things, that means that we'll have a valid blockchain. And so that's the final thing we need to do here, make that function. However, we're going to do that in 2 tutorials because in order to check this, and especially the second check we need to make, we need to implement a hash function. Well, we actually don't have to implement it, but we're going to use it several times, and therefore it's better to make a separate hash function that will hash each block so that we can have a more structured code. So we're going to make this hash function in this tutorial, and then in the next tutorial we will make that final function that we will call isChainValid, and that will check if the whole chain of our blockchain is valid. Alright, so let's make this quick hash function. I'm defining therefore a new function which will be a method of this class. So def hash, and what is this hash function going to do exactly? Well, it's going to take a block as input and it is going to return the SHA-256 cryptographic hash of the block. So it's going to take 3 lines of code. The first line to input the arguments that this function hash is going to take. So it's of course going to be self first because it's going to be a method of this blockchain class that we're building, and therefore a method that is going to be used in part 2 when mining our blockchain. And then the second argument it is going to take is of course a block. You know, any block in our blockchain. So self and block, colon, and let's define what this function hash has to do. So basically we are going to hash a block of our blockchain. So far each block of our blockchain has the following format. It's a dictionary with 4 keys, index, timestamp, proof, and previous hash. But the first thing we need to do, exactly as we did for this operation that we hashed in the previous tutorial, well, the first thing we need to do is make this dictionary a string. We can do this. We're going to use the JSON library, and from this JSON library we're going to use the dumps function that exactly takes an object and makes it a string. And why do we take the dumps function from the JSON library and not directly the string function? Well, that's because in part 2 we will put our blocks dictionaries into a JSON file, you know, in the JSON format. And therefore our blocks originally in a dictionary will have the JSON format, and that's why we need to take this JSON library and then the dumps function from the JSON library to make our block a string. So let's do this. That's the first step of this hash function we need to do. So I'm going to introduce a new variable that I'm going to call encoded block, because we are basically encoding our block into the right format so that it can be accepted by the SHA-256 cryptographic hash function from the hashlib library. And so this encoded block, how are we going to get it? Well, first we're going to take the JSON library, then as we said, the dumps function to make our block dictionary a string. So dumps function, and it is going to take 2 arguments. First our block, and then the sort keys argument, which will set equal to true, so that our block dictionary is sorted by the keys. Alright? But then we need to do exactly the same as what we did to hash our operation. We need to add this dot encode function to, you know, get the b before the string as it's required by the hashlib.sha256 cryptographic hash function. So that's exactly what we need to add here, dot encode, and here we go, we have our encoded block. Perfect, so now we have our block in the right format, the format expected by the hashlib SHA-256 function, and therefore we're ready to return exactly what we want to return, that is the cryptographic hash of our block. And you know how to do this. We take our hashlib library, then from this library we take the SHA-256 function, and inside this function we input our encoded block, which is in the right format, and then dot hex digest to get the hexadecimal format, exactly like what we did for our operation. Perfect. Now we have our hash function that returns the cryptographic hash of our block. So now we're ready to make this final function, which we're going to call isChainValid, and that will return true if everything is right in our blockchain, meaning if each block has a valid proof of work and if the previous hash of a block is equal to the hash of the previous block. So let's make that final function in the next tutorial, and until then, enjoy blockchains!